Hello everyone. In this video, we are going to explore a new feature in LuBan CMYK lithophane. CMYK lithophane is based on the white lithophane as well as three different colored lithophane, cane, magenta, and yellow. However, when you buy such colored lithophane from a filament manufacturer such as CMYK, you will find that they are not pure color, they are not pure cane, pure magenta, and pure yellow. What do I mean by pure lithophane? So let's click the link to CMYK at the United States. And by the way, this part of the feature update is largely owing to tests by LuBan user Robert Hansen. Thank you. So we go to the website CMYK cane. When you scroll down, there is a place that indicates the color code. This is a hex code, 16-based number, whereas we are familiar with 10-based number. So RGB, the maximum number is 255. In 16-based code, the maximum number is FF. F corresponds to 255. And if we have CF, then it's some number that's much smaller. And we can easily calculate 10-base number from a 16-base number. So let's take a look at this. The RGB code in hex code, 16-base number, is 00. So that means red is 0. This is a blue guy, so there is no red component. Then green component is 76. 76 means 7 times 16 plus 6. The 10-base code is 118. And lastly, the RGB blue code is CF. A is 10, B is 11, C is 12. 12 times 16 plus F is 15. So it's 207. So this information tells us the actual color code of the filament. It is not 00 FF. In 10 base digits, it's 0, 255, 255. That is pure cane. This is not pure cane. Whichever manufacturer that you go to, you will see that their color filament cannot make 100% pure. This has caused a problem in making CMYK lithophane. In LuBan CMYK lithophane, all the previous code was based on the assumption that you are using pure color. However, it is not the case. What do we do? Let's open LuBan software and then go to File, Create, Lithophane. I'm going to CMYK option, and you can load a image. I will choose a color image, baby shark. Immediately it shows invalid filament combination, invalid filament color combination. In the previous version, there is no filament section, but now there is a filament section. The first one is white. There is no need to change it. White is always assumed to be pure color, even though some manufacturer may not produce a pure white. I don't involve the white in the calculation in order to protect the strength, in order to protect the robustness of the calculation. I've only allowed users to change cane, magenta, and yellow. Apology. Okay. So let's set this to cane. And you can check the RGB code 0255. That's pure cane. And then magenta, this one. 2550, 255. Lastly, yellow. click OK. Okay. After you select this RGB, you will get a nice representation of the color lithophane. This is the ideal situation. What if your manufacturer does not give you pure cane? Let's say your manufacturer gives you blue. The blue doesn't have the green component. Green is 0. If you click OK, your lithophane will look like this. Your lithophane will be different from the original photo. There are two things going on behind the algorithm. The first thing is the new updated LuBan color mixing algorithm will use whichever color that you input, the actual color of your color filament, and try to find the best combination to reproduce the color photo. However, as the colors that you input is not pure color, sometimes and very often it cannot get the same image as the original photo, but it will try to do its best at producing a photo that has minimum color difference. As we see in this example, the cane component is changed to blue. Therefore, the best photo, the best color lithophane that you can get looks like this. It does not look like, it is a little bit different from the original photo. The original photo is a bit brighter, but we don't have cane, we only have blue, okay? Similarly, if I change magenta, let's choose a ridiculous color. We choose green. This is what's gonna happen. The three colors that we have is blue, dark green, and yellow. All these three colors lack red component, so the resultant best possible color lithophane looks like this. The red component is missing. And lastly, I'm going to do something with yellow. Although yellow has red component, these two are coupled together. There is no extracted red. I'm going to select pure red, and let's see what it looks like. Now the lithophane looks a bit better compared to the previous color combination. It's a bit better because now we have red components. So several baby sharks' face are similar to the original photo, but we do not have the yellow anymore. So the central, the small baby shark looks quite different from the original one. This is what the new feature gives you. And when you click Object, Select, you can see the top layer, which is a white layer. Then the second layer is still called yellow, but you can literally choose any color. Next layer below yellow is magenta. Again, you can choose any color. The third colored component is cane. You can choose any color. And the lastly, it's the base white. That one you cannot choose. Okay. That is basically what the new feature does. Several things to note. If you have two color filament that has the same color, you will get, oh, apologies, this is not exactly the same color. So let's choose, okay. So let's do an experiment. This is not the same color. Maybe if I set it to white, white still works. I select white again. Then it doesn't work. So the color combination that you arbitrarily set may produce calculation error. In this case, you will see a message, invalid filament color. Okay. When you see this, you'll know that you have to modify the colors. This is the first thing to note. The second thing to note is that if you press the shortcut E to expand these layers, These colors corresponds to the layers beneath it. So let me delete the top layer. The color layers that beneath the top one corresponds to the color that you select, even though the name is still yellow, magenta, cane. I didn't change the name. They are still these three names, but you can literally choose any color. In the most sensible case, you are going to choose a color that only deviates from the original one slightly. This is an extreme example. Robert Hansen gave me a color code of several of his filament. So in filament set 1, we can see that this is cane. Cane is green-blue. So green-blue component are strong, red component is not that strong. Magenta is red-blue. Red is very strong. However, his magenta, the set 1 is not very strong. So set 1 blue has a big deviation. Yellow component is red-green. Red-green is pretty strong, but the blue component is also quite strong. And let's see if we input these numbers to the Baby Shark example, what do we get? 23, 205, 218. That's the first color code. 23, 205, 218. Click OK. That's his actual color, cane color. Next, magenta, 215, 24, 82. 215, 24, 82. That's the actual magenta he got. And lastly, the yellow, 223, 238, 119. 223, 238, 238, and 119. This is the yellow. It's a bright yellow. When you set the three actual filament color, you get an image that looks like this. Quite close. They are quite close to the original photo, but there is slight deviation. May I remind you again that this is the optimum color combination that LuBan has calculated that produce the smallest color error from compared to the original photo. If you use some other types of combination, you may get worse results. This is the best you can get. Let's take a look at the second set. In the second set, cane is the red component is even less, so it's a little bit better than this one, even though the green is not as good. Magenta is red and blue. However, the green component is fairly strong. So this magenta is not very strong magenta. Yellow is green is red and green, but the blue is quite strong. Let's see which one of these two sets produce a better result. For comparison, I'm going to click New to copy the set 1 results. Now we are going to deal with set 2. 6184, 255. 6184, 255. Okay, that's cane. Then 216, 199, 211. 216, 199, 211. You see the magenta is really weak. It's not a strong color. Lastly, 214, 219, 126. 214, 219, 126. The yellow is also not that strong. And this is what you get. Okay. Because of the poor magenta, lacking red component, the second set produces results that are not as good as the first set, in my opinion. Okay. And the original photo looks like this. That is pretty much all in this video. I hope you enjoy this function. And this This new feature will help you fine-tune your color lithophane. Last but not the least, in the lithophane shape options, the stencil as well as the box method also has an option of, so this is the stencil lithophane. I have chosen a white circle as the template. Both stencil and the box method has the option of CMYK lithophane. When it is set to no, the default option, you get only one filament. But when you set yes, you will get the 3 filament color. Okay. Both stencil and box method has this feature already. Okay, that's it. So you can use CMYK lithophane on stencil lithophane as well as box lithophane. That is all for today. Thank you very much.